Okay, in this video we're going to learn about the key features of functions. I'll go through a few of these and tomorrow we'll explore the rest, but we've already done domain and range. The other key features are whether or not the function is even and odd, where it's increasing and decreasing, where there may be a minimum and maximum points, where the function's positive and negative, what the x and y intercepts are, and what the end behavior of the graph looks like. So going through these slides, I'm just going to use one function so I don't confuse you. I'm going to just pick the quadratic function, and the equation of this is y equals x squared minus 3. So going through these, I'll give you a few definitions, and if you just want to write those down, that'll help you out tomorrow. Even function is where the graph reflects across the y-axis and is perfectly symmetrical. And an odd function is where it is symmetric with respect to the origin. So looking at this quadratic function, you can see I already drew the red line at x equals 0. This is the y-axis, and this reflects perfectly across the y-axis, so therefore it is an even function. If it was an odd function, you would have one arrow going up and one arrow coming down. Okay, increasing and decreasing. I think that's pretty self-explanatory. Just know that you're going from left to right as always. So you know this arrow says that it goes all the way up to infinity. So coming left to right, negative infinity, we're coming down, so we are decreasing. And then right at this minimum point, at x equals 0, we are going to turn around and start increasing. So a function is increasing when the y values increase as the x values increase, going from left to right, remember. And a function is decreasing when the y values decrease as the x values increase. So looking at this graph, it is increasing on 0 to infinity. So remember, we're just looking at x values. At x equals 0, we are down here at negative 3. It is increasing from 0 to infinity. So if I trace from 0 to infinity, you would just keep going up and up and up. Decreasing, it is decreasing from negative infinity to x equals 0. Minimum and maximum. You should be able to look at the graph and just point out where the minimum and maximum values are. So the minimum at this case is down here. I just think of it as your hills and valleys. This is a valley, so it is a minimum. Right down at the very tip bottom is a minimum. If this were flipped and it looked like an N shape or a mountain, then you would have a maximum. So we're going to have relative minimums and maximums and absolute minimums and maximums. In this case, our relative and absolute minimum are both this point down here. Tomorrow we'll look at a few examples of where you will have local minimums and different absolute minimum or maximums. I just noticed that there is a typo, so this should say absolute maximum is the highest point of the function. So let me change that real quick. Okay, so looking at this graph, the local or absolute minimum is at x equals 0, and that minimum value is at negative 3. So you would write that just local and absolute minimum at x equals 0, and the minimum is y is equal to negative 3. Okay, just get these definitions down. Know that relative and local are just in a certain area, so just where it's changing from increasing to decreasing or decreasing to increasing. An absolute maximum and minimum is the very, very, very highest point of the function and the very minimum point of the function. So in this case, this graph does not go anywhere below negative 3. However, the maximum value, it keeps going up and up to infinity. So we actually do not have a maximum value because infinity is not a finite number. Okay, positive and negative. A lot of you will probably get caught up on this one the most. Positive is just where the function is above above the y-axis. Excuse me, the x-axis where y is equal to 0. So where our function is greater than 0 will be everywhere that the y values are positive. So our function is positive above the x-axis. So I just drew a little blue box around everywhere that it's positive. It's negative when the function is below 0 or below the x-axis where the y values are negative. So it is negative right in here. Now you're going to use intervals, and intervals, remember, you're just looking at the x values. So it is positive from negative infinity to negative 2, and then you're going to stop. Then it starts going negative. So you got to stop, jump over until the very next point that it's positive. And from 2 to infinity, it's also in the blue box. So if you want to get a highlighter and highlight everywhere above the x-axis and everywhere below the x-axis, do that. So here's how you would write positive. Negative infinity to negative 2 is in the blue box. And then 2 to infinity is in the blue box. And then for negative, negative 2 to 2. So just from negative 2 to 2 is below the x-axis, so it is negative. Just look everywhere that you have y values that are negative and y values that are positive will determine where the graph is positive and negative. Okay, so now I want you to do this function for homework. I want you to tell me what type of function it is. Bring in at least 3 questions from the video to class tomorrow and determine all of these key features. I still want you to do domain and range. I want you to maybe look up in behavior and tell me what you think it might be. You should know the x and y intercepts and the other ones we just talked about. So do this assignment, bring it in class tomorrow, have it ready on your desk, and I'll come by and check it. Have a great night.